So how could I use my area function? Okay, there's a good suggestion, right? I know that I'm asking, when does the area equal 99,099? So I'm just going to make that substitution and solve, right? So we end up then with the equation. If we do that, I end up with the equation negative 3x squared plus 636x equals 99,099. Okay, so now we just can flip into algebra mode and we're going to solve that quadratic equation. Okay, anything we could do to make that a little bit easier? What would my first step be there? Just type it in chat. What do I have to do first to solve that green equation?
Would you move all the parts on the left side to the right side?
Yeah, or either way, left to the right or right to the left. Now you're thinking left to the right so you get a positive coefficient of x squared, correct? Okay, good. So if we move everything on the left to the right, we want to set this thing equal to 0, don't we? We want to put this into standard form. Okay, good. So if we do that, if I move everything over to the right side, what am I going to get? I'm going to get positive 3x squared minus 636x plus 99,099. And I'm going to go ahead and just flip those so they're on the left instead. Those all equal 0, right? Okay, what else? Could I make that a little bit easier? Anybody? Do you see something I could do that would make it a little bit better? Oh, good. I could divide by 3, couldn't I? Divide both sides by 3. Good job. Okay, so if I divide each side through by 3, that's going to give me a little simpler equation. X squared minus 212x plus 33,033 equals 0. Okay, now what? How would I probably choose to solve that, do you suppose? I know what I would do. What would you guys do to solve that thing?
Quadratic formula?
Yeah, I'd use quadratic formula, right? It might factor, but who wants to try with those big numbers, right? So we would just use quadratic formula. So x equals negative b, so that's positive 212, plus or minus the square root of negative 212 squared. We'll just square positive 212, minus 4 times 1 times 33,033, right? All divided by 2. So what's that give us? Well, we're going to have to do a little calculator work on this. Let's pull up Desmos. How about? Oops. Okay, so we get what's that give us? 212 plus square root of, need that do it, 212 squared minus 4 times 33,033. So maybe I gave you a problem that can't be solved. It's possible. It's telling us that's undefined. What do you think it's, why do you think so? We have to be able to solve this. Something.
Are they imaginary solutions?
So yeah, so it must be that there are negative solutions on this. So this must be, you must never be able to have that area. So I didn't do a very good problem here, did I? B squared minus 4ac. Okay, let's look at another technique we'd have for this. Let's go ahead and I'm going to put that one away for a second. Let's graph this thing, because if you have access to a graphing calculator, remember that's an easy way to solve this thing, right? If we want to look, if I want to solve an equation, I could just find the zeros of that equation. Okay, so let's, you know, the x-intercept. So let's go into Desmos again, Desmos graphing, and let's graph this thing. So we've got, we're going to graph the function f of x equals x squared minus 212x plus 33,033. Let's see what that looks like. Okay, so we obviously have to zoom out a bunch to be able to see this thing. Okay, there it is. So let's tweak this graph a little bit. So the x-axis, let's just go from, we don't need this, we're going to stretch this thing out on the x-axis. So let's just go from like negative 100 to positive 100 and see what that looks like. So we've got to go a little more than that. So positive 600, there we go. Okay. And I must have, so okay, so look, that one doesn't have any solutions, does it? Okay, so no x-intercepts, okay? All right, so that's the answer to the first one is Mr. Roya made a bad problem. What dimensions would result in that area? You can't do it, so there are no dimensions. So let's do the next part. What dimensions would maximize the area of the pasture? Okay, how would we do that? So now we've got this, I don't know what color that is, but the question down here at the bottom, how could we take our area function and find the maximum area possible? What would that look like? The green question, we just set up an equation that we were going to solve, but there was no solution. How would I solve that bottom? How could I go about that? What's my strategy? Somebody just, rather than type it in, just describe it to us, somebody. Somebody, be brave. How am I going to find the dimensions that would maximize the area of the pasture? And think in terms of what this graph is going to look like. You know, what form is this in up here, this area function, this red area function? It's a quadratic function in what form? Is that standard or vertex? This guy right here.
It's in standard.
Yeah, it's in standard, isn't it? So what's the value of A, everybody? Just type it in. So is it opening up or down? Okay, good. It's opening down. So let's think about what our graph would look like, our area function graph. It's going to be a parabola that opens down, right? If I'm trying to find the conditions that are going to maximize the area, where is that going to appear on my graph, right? My graph is, it's x versus, or it's area versus x, right? So my input is x, the width of the pasture, and my output is area. Okay, so we're looking for the vertex then, aren't we? Right, because we know we're going to have a parabola that opens down. The maximum area in this case is going to be the y-coordinate of the vertex, right? Okay, so we need to find the vertex. That's our goal. How are we going to do that with this area function? It's in standard form, so this goes back to last unit, right? How do we find the vertex of a quadratic function? Yeah, put it in vertex form. And we don't even have to probably write the whole thing out in vertex form. We just need to know the coordinates h and k, don't we? Right? So what's our formula for calculating h? If we've got a quadratic function in standard form, what's our formula for calculating h? Everybody type that in. It's good to remember this stuff. You got to force yourself to remember that. Everybody remember what that was? There you go. Chloe got it. Negative b over 2a, right? H is negative b over 2a. Or if you wanted to, of course, you could always just complete the square, right? To put this into vertex form. That's just kind of hard to do. Well, I mean, I don't know how hard it is, but there's, that takes a little bit more work to put that into vertex form. So we can just use this shortcut. So negative b, that's going to be negative 636 divided by 2 times a, that's negative 6. And so then what's h equal? Positive 106. Is that right? Yeah, positive 106. And then if I want to find k, I'm just going to evaluate my function at 106, right? So if I plug 106 into my function, what do I get? And we could certainly use Desmos for that. So if we want to do that, we want to evaluate our function at 106. This is a prime case for what a useful application of Desmos, even the scientific. Even if we don't have the graphing one, we'll just enter our function. Actually, it's a of x, isn't it? I should do a of x. A of x equals negative 3x squared plus 636x. And then I'll just evaluate my area function at positive 106, and I get 33,708. So that's the biggest area we can get. Okay. I'll take a picture of that. How about instead? Okay, so then there's our output. So we know the coordinates of the vertex are at 106, 33,708. And so they want to know what dimensions would result, or what dimensions would maximize the area. So we know x is 106. How would I find the width then that goes with that? How would I find the width? Or the, whatever we call it, the length, y. So what am I going to do there? How am I going to find y? They want the dimensions. So I know x, which is the width of our pasture, is 106. How do I find the length of the whole of the pastures? I could do that. Rebecca said divide the area. I could divide the area by 106. That would work. There is maybe a little bit easier way. I guess it's a little easier. Okay, everybody see up here? I shouldn't have put a box around that first one. I'm going to see if I can undo that box. There we go. Right, so when we get to calculus, I will reinforce this again and again and again. When we're doing something where we're making a substitution, we used our equation of constraint, that 636 feet of fencing equation, to solve for y so we could make a substitution. Always put a box around that because you're likely to come back to it. If I want to ever be able to evaluate y, this is the boxed equation is the one where y is isolated. And so that's the one where I could easily plug in a value for x. Everybody see that? So all I'd have to do is plug that value in there. I'd get 636 minus 3 times 106. So what's that going to be? 3 times 106 is 318. So so I get 318, wouldn't I? Right? So my dimensions would just be 106, and then I'm going to get y from that equation. Y equals 318. And so those would be my dimensions. Everybody see that? Okay, so always when you're making a substitution, you may not always need it, but it's always a good idea to put a box around that substitution equation, because then in all your work, because your work will get dense as you go further in math, there's going to be, your pages of math are going to look messier and messier because there's a lot more stuff you're going to be doing. It's easy to find that boxed substitution equation. Okay, and then we could verify this all if I just graph the function. Let's go back into Desmos graphing for a second, and let's graph our area function. So if I graph my area function, a of x equals negative 3x squared plus 636x, well, what do you know? There's my vertex at 106, 33,708, right? So we could have found it that way too, okay, if we had a graphing utility available. Okay, everybody good with that? Give me 1 to 5 on that problem. Okay. Yeah, there's a lot going on there. Okay, good. Let's try one more of those. How about this one? One leg of a right triangle is exactly twice as long as the other. Oh, I want to go one thing before we go any further with that. I wanted to mention one thing. So did we really need to have that y there? I mean, it was convenient, but could we have skipped directly to this equation, to our area function, x times the quantity 636 minus 3x? I would say that, yeah, you probably could, right? If you thought about this as 636 feet of total fencing, and we were going to define the perpendicular, the parts of the fence line perpendicular to the river, if we call those x, then we know that there's 3 of those, right? If there's a total of 636 feet of fencing, couldn't we reasonably maybe have just gone right to that equation right here? Did we really even need to do all that stuff? Could we have just gone right to that equation? Yeah, we probably could have, right? Did we even really need to define it in terms of x and y? Yeah, maybe not. Everybody agree with that? We could have, in our mind, we could have probably just kind of conceptualized that and said, well, if we take the full 636 feet of fencing and we subtract away 3 x's, that's going to give us what's left over for the length of the pastures. And so that's maybe how we could get that other dimension there, that 636 minus 3x. Okay. Either way, though. Okay, how about this one? One leg of a right triangle is exactly twice as long as the other. The hypotenuse is 4 centimeters longer than the longest leg. What are the lengths of all three sides? Any suggestions how I got to be able to set up an equation that I can solve here, right? So my goal is then, how many different kinds of unknowns can I have in my one equation to be able to solve it? One, that's right. Okay, right? If I've only got a single equation, I can only have one type of unknown, call it x, right? Got to be able to write this whole thing in terms of x's. How could I come up with an equation there? Well, let's start off with a picture. It's always helpful to have a picture for stuff like this. Okay, so there's my picture, right? It's a right triangle. What could I do? How could I label those sides? What about this first statement up here? One leg of a right triangle is exactly twice as long as the other.
You could do like the shorter one is x and then the longer one is 2x.
Okay, good. Okay, go hold that thought. I'll get right back to you. So we got x and 2x. Good. Okay, Sarah, what else were you going to say?
And then the hypotenuse would be 2x plus 4.
Okay, good. So if we look at this green statement then, the hypotenuse is 4 centimeters longer than the longest leg. Well, there's the longest leg, right? So this would have to be 2x plus 4. Okay, good. All right. Okay, somebody else. How could I come up with an equation then?
You can do the a squared plus b squared equals c squared.
Yeah, I could use Pythagorean Theorem, couldn't I? Good. So we could say x squared plus the quantity 2x squared equals the quantity 2x plus 4 squared. Everybody agree? Okay. So now we just have to solve that thing, right? So what do we do here? So if we expand all this stuff out, what am I going to get there? What is the quantity 2x squared? Type it in chat, or just say it out loud, somebody. What is that? What's that second term on the left going to be? 4x squared, good, okay. And then over here, I've just got to FOIL that thing out, don't I, right? For now, that's what we're going to do. When we get to the next unit, we'll learn some shortcuts for that. And you might already know it, but I could just do this, right? If I FOIL that out, distribute the 2x, I'm going to get 2x times 2x is 4x squared. 2x times 4 is 8x. And now when I distribute over here, I'm going to get plus another 8x. And then plus 16, right? So there's my equation. Now I've got to put that equation into standard form. So I could subtract all these things on the left from both sides. Actually, let's not do that. Let's combine like terms. Here, let's do this. Let's go. So x squared plus 4x squared is 5x squared equals 4x squared plus 16x plus 16. Now I can move everything over to the left side, agreed? Set it equal to 0. So that's going to give me x squared minus 16x minus 16 equals 0. Everybody agree? Give me a 1 to 5, everybody. How we doing so far? Okay, okay. Now we have a quadratic equation in standard form, and so all we have to do here is just solve this thing, right? Okay, so this is one, it's not going to factor, is it? So we're just going to use quadratic formula. So x equals negative b, so that's 16 plus or minus the square root of 16 squared, so that's 256, minus 4 times negative 16. So minus a negative, that becomes positive, doesn't it? If I multiply two negatives, I'm getting positives. Divided by 2. So what's this going to give me then? 16 over 2. I can split this up. I'm just going to get 8 plus or minus. Now, what's this going to give me here? 256 plus 64 is 320. That's not a perfect square, but we should be able to coax something out of that. Probably, is that 64 times 5? It is, isn't it? Everybody agree? 320 is 64 times 5. And 64 is a perfect square. That's 8 times 8, right? So we get a couple of 8s and a single 5. So we get x equals 8 plus or minus 8 radical 5 over 2. And look, I could simplify that to a 4. So I get x equals 8 plus or minus 4 times the square root of 5. Okay, are both those good solutions? Talk to me about those solutions right there.
Well, length can't be negative.
Go ahead, Abby. You're right. So which one can I get rid of, Abby?
You can get rid of the minus sign, so the only solution would be 8 plus 4 times the square root of 5.
There you go. Good. We know that everybody agree that 4 times the square root of 5, that number is going to be bigger than 8, isn't it? Because the square root of 5 is bigger than 2, right? Square root of 4 is 2, so the square root of 5 is bigger. So I can cross out that negative sign, can't I? Right? We're only going to keep the positive. And so we end up then with, if x is equal to 8 plus 4 times the square root of 5, we could find all the other dimensions based on that value of x, right? So then if we were to plug those values in, here I'm getting 8 plus 4 times the square root of 5. Down here we're getting 2 times that. So if I distribute a 2 through there, I'd get 16 plus 8 radical 5, right? And then what about up here? Well, I'm getting the longer one plus 4. So if I add 4 to that number, I'm just getting 20 plus 8 radical 5. So there are the exact dimensions of that triangle, right? Anybody see that? That's kind of cool. We can do that. Okay. 1 to 5. Okay. You'll get a little practice with this stuff. And then, okay, then I just wanted to, you're going to run into something like this potentially. Okay, how could we solve this equation, do you suppose? And this is kind of looking ahead a little bit. This is really We'll deal with more stuff like this later in the year. But we can even do this one now. How do we deal with fractions like that? What do we have to do when we're adding up fractions? How do I always add fractions, even if they have variables in them? We need common denominator, don't we? Right? We need a common denominator to add those fractions on the left. Okay? So how could I do that then? I've got 1 over x plus 1 over x plus 2. How could I get a common denominator on the left side? What would it be? What would my common denominator be? And I want you to think in terms of what you do for numbers. What if I was adding up 1/2 plus 1/3? What would my common denominator be there? Be 6, wouldn't it? I'd get that by multiplying. It'd be the product of those two, right? Okay, so what's my common denominator going to be in the black equation then on the left side? Okay, so it's going to be x, the product of x times x plus 2, right? Everybody agree? So to get a common denominator then, I'm going to have to multiply each of these by 1 in the form, the first one I'm going to multiply by x plus 2 over x plus 2, right? And what about over here? I'd have to multiply this one by x over x, right? Everybody agree? Okay, but what about on the other side? On the other side, I've got a 1/4, right? So I'm going to want to maybe on the other side also get, well, we can do this a couple ways. We won't even worry about that for a second. Let's just work on the left side. So then I'm going to end up, if I multiply straight across, I get x plus 2 divided by x times x plus 2 plus x divided by x times x plus 2 equals 1/4. Okay? Well, I've got a common denominator, so I could write the left side as one big fraction, right? I could write that as x plus 2 plus x divided by my common denominator, x times x plus 2 equals 1/4, right? I could simplify this. X plus 2 plus x is just 2x plus 2. Okay, so now I've got a proportion. What happens if I have a fraction equal to a fraction? How do we solve that? We did a little bit of this at the very beginning of the year. Do you remember how we always solve a proportion? There's a really easy way. If I have a single fraction equal to a single fraction, what can I do? Cross multiply, exactly, right? So if we cross multiply, we're going to get a blue cross product equals a red cross product, right? So if I cross multiply, then what's my blue cross product going to be? 4 times the quantity 2x plus 2 equals my red cross product, which is 1 times x plus 2, right? And now we can see that I could turn this into a quadratic equation in standard form eventually. If I distribute the 4 over here, what am I going to get? 8x plus 8 equals, if I distribute the x squared plus 2x. And let's just scoot everything over to the right side to set it equal to 0. And what's that going to give us then? X squared plus 2x minus 8x would be minus 6x minus 8 equals 0. But let's just put the equals 0 on the right. Okay, how would I got a quadratic equation now, right? in standard form. How do I solve that one? Does it factor? Doesn't factor, does it? Okay, so we probably just want to use, this would be an easy one to complete the square on. I mean, we could, of course, use quadratic formula, but because a is equal to 1 and b is even, we could just complete the square. Let's do that. We never do that. Let's try that once. So I've got x squared minus 6x equals 8. What's the number I would have to add to both sides to create a perfect square trinomial over here to complete the square? Type it in chat. Everybody, type that in chat. What number would I have to? There you go. Good, good. Because we see that, look, we can see over here that b is equal to -6. So half of b is -3. And I'm just going to add half of b squared, which is 9, right? And so I end up with, what's that going to factor into? My magic numbers, if I made that, that's a 9. What numbers multiply to 9 and add to -6? Well, what do you know? -3 and -3, right? So I get x minus 3 quantity squared equals 17. And now I could just square root both sides and add 3, right? So I'm getting x equals plus or minus the square root of 17. And then I'm going to add my 3 right there, aren't I? Right? So there are my solutions to that. Okay, everybody see that? Just wanted to lead you through that once. I think there's one problem. It might even be like a bonus problem on there, but there's one where you have to do something like that. Give me a 1 to 5 on that. Does that make sense? Once again, to recap, where did the 3 come from? Let's see. Where'd the 3 come? Okay, because that, you mean this 3 right here, Rebecca? Is that right? Is that the one you're talking about? That one? Yeah, okay. That comes when we're completing the square. It comes from the fact that if I look what we have, this equation. Let me take this equation and just write it this way. So I've got x squared minus 6x plus 9 equals 17. Well, what are the magic numbers here that multiply to 9 and add to -6? That would be -3 and -3, right? So that's where we're getting that -3. Right? We purposely added 9 to both sides to create a perfect square trinomial. Okay, but we know the pattern is whatever half of b is, I need a new color here. I guess we'll use pink. How about whatever half of b is, that's always going to be the magic number that shows up twice. Okay, does that make sense? Okay. All right, and of course we could have used quadratic formula on that too. Would have been just as easy, if not easier, to use quadratic formula. Okay, but that is pretty quick to do when you have one that's just served up to you like that, where were we on this? Where a is equal to 1 and b is even. That makes completing the square really simple, doesn't it? Now, if b were odd, you'd get fractions. You probably wouldn't want to do it. Or if you had a with something other than 1, you might not want to do it, right? Because then there's too many steps to complete the square. But if a is 1 and b is even, it's a one-step process. It's pretty simple, okay? All right, questions on anything? Okay, I'm going to let you guys work. So I will have, remember, the test will be available on Wednesday. I'm going to give you a test day on Wednesday and Friday. So I'll give you a freebie attempt on Wednesday. So anything you do on Wednesday, I will delete that if you want me to. It won't count towards your 2 attempts. It's just a freebie. But if you'd rather use that time to work on stuff and get some questions answered, that's fine too. Okay, but if you can, I'd encourage you to use that time to test. All right, we good? Work away. I'm here to answer questions. whatever time is left. How much time do we have left? Oh, 3 minutes. Never mind. I'm going to let you go a couple minutes early then. You get up and stretch a little bit and get a snack. Only a few minutes left. I'll be here after school if you need any help with anything. See ya.